Beneath the tranquil pine forests and the bustling ski slopes of eastern California, where winter sports enthusiasts flock each year, a hidden force is quietly awakening. This region, known for its natural beauty and outdoor adventure, sits atop a sleeping giant that few visitors ever consider. Deep below the surface, a geological giant is stirring, sending subtle but unmistakable signals that the land is alive and restless. The Long Valley Caldera, one of only 2 supervolcanoes in the United States, is showing renewed signs of activity. Scientists have detected ground swelling, a surge in thousands of tiny earthquakes, and the release of volcanic gases seeping up through cracks in the earth. These are not random events, but clues that something significant is happening beneath our feet. This isn't the plot of a Hollywood disaster movie. It's a real, ongoing process, unfolding deep within the Earth's crust. The forces at work here are ancient, powerful, and unpredictable. The implications of a major eruption would reach far beyond California's borders. Air travel across North America could be grounded, weather patterns might shift, and global economies could feel the shockwaves. The interconnectedness of our world means that a single event here could have ripple effects across continents. The last cataclysmic eruption, more than 760,000 years ago, blanketed the landscape in ash, with deposits found as far away as Nebraska. This ancient event reshaped entire ecosystems and left a geological record that scientists are still deciphering today. Today, thanks to cutting-edge technology, researchers can peer into the heart of the volcano with unprecedented clarity. Seismic sensors, satellite imagery, and computer models are transforming Long Valley into a global case study in both risk management and resilience, offering lessons for communities living in the shadow of other volcanoes worldwide. Understanding what's happening beneath Long Valley isn't just about local safety, it's about unlocking the secrets of the powerful forces that have shaped, and continue to shape, our planet. The story unfolding here is a reminder of Earth's dynamic nature and our ongoing quest to coexist with it. The magma is on the move, and scientists are racing against time to decode its signals. What happens next in California could offer vital clues for the world as we strive to understand and prepare for the awesome power of our restless planet. To grasp Long Valley's scale, we must travel back over 760,000 years. The caldera, a vast 20 by 10 mile depression, was born from a super-eruption that dwarfed anything in human history. The blast was 2,500 times stronger than Mount St. Helens in 1980, ejecting 150 cubic miles of rock and ash. The ground collapsed, forming the enormous basin we see today. Pyroclastic flows incinerated everything for hundreds of square miles, and ash blanketed the continent. The Bishop Tuff, a thick layer of volcanic ash, still marks this event across North America. Today, Mammoth Lake sits on the rim of this ancient scar, its hot springs a reminder of the lingering heat below. The caldera is not just a relic, it's an active, evolving system, a humbling reminder of the power beneath California's tranquil surface. For decades, Long Valley was thought dormant, a sleeping giant nestled quietly in the eastern Sierra. Its vast caldera, formed by a cataclysmic eruption 760,000 years ago, seemed peaceful, a landscape shaped by ancient violence but now at rest. Locals and scientists alike believed the volcano's fury was a thing of the distant past. But everything changed in the late 1970s. In 1978, a series of earthquake swarms, clusters of small quakes, rippled beneath the caldera, sending the first hints that the volcano was stirring from its long slumber. These tremors were unlike anything seen in decades, and they caught the attention of geologists around the world. Then, in May 1980, 4 powerful magnitude 6 earthquakes struck in rapid succession, shaking the region and alarming nearby communities. Even more startling, the ground within the caldera swelled upward by nearly a foot, a dramatic sign that something was happening deep below the surface. This was clear evidence that new magma was intruding into the system, pressurizing the underground chambers and forcing the Earth to bulge. Scientists raced to understand the implications, knowing that such activity could precede a major eruption. The unrest didn't stop. Throughout the 1980s, 1990s, and early 2000s, Long Valley experienced repeated swarms of earthquakes and continued ground uplift. The land itself seemed to breathe, rising and falling as magma moved and pressure built beneath the surface. Over time, a 100-square-mile area rose by an astonishing 2.5 feet, a clear sign that the volcano was recharging. This ongoing uplift is one of the largest ever recorded at a caldera in North America. Today, Long Valley is recognized as one of California's most hazardous volcanoes. Experts estimate there's a 16% chance that one of the state's volcanoes will erupt by 2050, a sobering statistic that keeps scientists vigilant. Each quake, every subtle shift in the ground, is a message from the deep. Teams of scientists work tirelessly, monitoring seismic data and ground deformation, striving to interpret these signals and provide early warnings to protect lives and property. The question is no longer if Long Valley will erupt again, but when, and how big that eruption might be. The caldera's story is still unfolding, and its next chapter could reshape the landscape and the lives of everyone nearby. Traditional seismometers and GPS gave us only a partial view of Long Valley's inner workings. In 2023, Caltech scientists transformed a 100-kilometer fiber optic cable into thousands of seismic sensors using distributed acoustic sensing, or DAS. This single cable became a dense network recording over 2,000 seismic events in 18 months, most too small for older instruments to detect. These microquakes reveal the fine-scale structure and fluid movement within the volcano. Machine learning algorithms sifted through the torrent of data, pinpointing quake types and locations. The result, a high-definition 3D model of the caldera's interior, revealing secrets never seen before. This revolution in monitoring is changing how we understand and anticipate volcanic hazards. The fiber optic network has given scientists the most detailed 3D image ever of Long Valley's subsurface. Instead of a single cauldron of molten rock, the caldera contains a deep magma chamber and a shallower system of superheated water and gas. The main magma reservoir, 12 kilometers down, is cooling and crystallizing, slowly solidifying over geologic time. As it cools, gases and fluids are forced out, migrating upward through fractures. This migration drives the ground swelling, earthquake swarms, and gas releases seen at the surface. The current unrest is not necessarily a prelude to a super-eruption, but a consequence of the chamber's slow demise. The real threat may come from the pressurized fluids rising into the shallower crust. The cooling magma chamber might sound reassuring, but it brings new hazards. As the chamber crystallizes, it releases gas and superheated fluids, pressurizing the rock above. This increases the risk of smaller, but still dangerous, steam-driven or magmatic eruptions. Phreatic explosions can hurl rock and ash for miles. Small magmatic eruptions could devastate mammoth lakes and disrupt infrastructure. The persistent ground swelling and microquakes are signs of this relentless upward migration of fluids and gases. While a super-eruption is unlikely in our lifetime, the probability of smaller hazardous events may be rising. Monitoring and public safety planning must adapt to this evolving, unpredictable threat. Monitoring Long Valley requires a sophisticated, multi-layered approach. The USGS's California Volcano Observatory tracks ground deformation, seismicity, and gas emissions, the volcano's vital signs. GPS and satellite radar detect even millimeter-scale ground changes, while a dense network of seismometers and fiber optic sensors records constant tremors. Scientists analyze quake patterns and gas emissions, watching for warning signs like increased carbon dioxide or the sudden appearance of sulfur dioxide. Any acceleration in ground swelling or a shift in earthquake activity could signal an impending eruption. This real-time data is crucial for forecasting and early warning. Vigilant monitoring is our best defense against the unpredictable nature of Long Valley. Even a small eruption at Long Valley could have profound impacts. For Mammoth Lake's residents and tourists, an eruption would mean evacuations and threats from ash, pyroclastic flows, and mud flows. The local economy, built on tourism, could be devastated for years. Critical infrastructure like the Casa Diablo geothermal plant is at risk, and ash clouds could disrupt aviation across the western U.S. Scientifically, an eruption would offer invaluable data for improving volcanic forecasting worldwide. The real risk is not just a super-eruption, but smaller, more likely events that could cripple the region and test emergency response. Ongoing unrest is a reminder. This is a real hazard demanding respect, preparation, and constant vigilance. The story of Long Valley is far from over. This vast caldera, shaped by ancient cataclysms, continues to hold secrets beneath its tranquil surface. While the landscape may appear calm, the forces that shaped it are still at work, hidden deep below. Every day, scientists and local communities live with the knowledge that the ground beneath them is alive, constantly shifting and evolving. New discoveries reveal a more complex threat, one that goes beyond the fear of a single massive eruption. As the magma chamber cools, it pressurizes the crust above, increasing the risk of smaller, unpredictable eruptions and ground deformation. These subtle changes can be difficult to detect, making ongoing research and vigilance even more critical. To meet this challenge, scientists are expanding fiber optic monitoring networks across the caldera. These advanced sensors can detect the tiniest tremors and temperature shifts, providing real-time data from deep within the Earth. With each new cable and sensor, our understanding of Long Valley's inner workings grows more detailed and precise. The ultimate goal is to move from simple observation to true anticipation, using cutting-edge technology to predict volcanic activity before it becomes a threat. This means giving communities the earliest possible warnings so they can act quickly and stay safe. Public education and emergency planning are as vital as scientific innovation. Regular safety drills, school programs, and community meetings ensure that everyone knows what to do if the volcano stirs. Preparedness empowers people, turning fear into resilience. The lessons learned at Long Valley reach far beyond California. They help create a global blueprint for monitoring and managing supervolcanoes, fostering international collaboration and sharing of life-saving knowledge. We can't stop the magma, but by listening to the whispers from the deep and preparing for what they foretell, we can coexist with the immense power beneath our feet. Every seismic signal, every plume of steam is a message from the Earth, one we must learn to interpret. Long Valley is a reminder. The ground is never as stable as it seems, and vigilance is our best ally. In the shadow of the supervolcano, awareness and preparation are the keys to living safely with nature's most powerful forces.